Hello and welcome to the second video of my Pygame coding tutorial. Now, for the observant, you may have noticed the background is black, whereas in the example I had showed toward the start of the last time, the background was white. Well, this is a very easy fix. I just simply forgot to do it. And all you really have to do to make it work is you say game window, or the name of your game window, dot fill with then whatever color you want. If we wanted white, then it would be 255, 255, 255. And now when we go to run it, you'll notice the background is white. Of course, we could make the background red or blue. It doesn't really matter. But this is how you do it. Since the game window is a surface itself, it is an actual surface object, a Pygame surface, you can just call fill, much like how we called fill when we created our own Pygame surface of 15075 and we said fill. It works the exact same way, which is why if we wanted to, when we say gamewindow.blit, what we can also technically say is surf.blit, and then we can blit something onto the surface, say another image, and we'll see this not this time, but later. Because this video, what we're going to focus on is moving objects. So I have my example again, and once I run it real quick, here we go. I like having these examples just to kind of give you an idea on maybe this video is something you're interested, maybe it's not. So of course there's a couple discrepancies, like these things are positioned differently, and this box is not as thick, but that's just because I do the actual video slightly different than I do my example. But you'll notice, look at this blue box. It's magical. It moves really fast, actually. To be honest, the thing is only moving 1 pixel per frame, but when you consider it's 1,000 frames, we're getting quite a few frames per second since we're not limiting it. We might limit it in this video, not too sure, but also, you probably can't hear, but I'm only actually clicking the arrow keys once for continued movement. So maybe you can if I move the mic closer. I don't know if you can hear that. Maybe, maybe not. I can. But that doesn't really matter because it really depends if you can. Anyway, we're going to make this so we just have to click and hold the arrow button down so that we can move it without having to constantly tap. But we'll go through the motions to get this thing working. So, how do we want to do this? Well, the blue box, how would I say this? We can do this as easily as just creating, something called position X equals, 500, position Y equals 200. And then when we blit our surface, we can just call it position X and position Y. And then, somewhere in our code, say position X, plus equals 1. And then if we actually were to run this, you would notice maybe, oh, it would move it if we didn't constantly reset this thing. So let's move this stuff outside of the loop. So I'm going to put it up here. There we go. Now it should be all good. So now we should watch this green box just zip away. Because what we're telling it is we're saying position X is 500, position Y is 200. And then when we actually get inside of the game loop, what we're doing is we're saying draw at position X and Y, and then increase position X by 1 every time you go through this loop. So what that's causing is it's causing the effect of having the X position where we're drawing the box move forward, and then of course the green thing just kind of shoots over to the side. Now, I do want to point out about this gamewindow.fill because we added this in and I want to show you what it's really doing. So let me comment it out. We're going to go back to a black background, but you're going to see kind of what it does. So now the box isn't moving, it's just redrawing itself. Well, what's happening in this occasion is the box gets drawn and then it moves 1 pixel and then it gets drawn again and then it moves 1 pixel and it gets drawn again, but the old image doesn't go away. But when we fill the entire game window with white, what essentially we're doing is we're blanking out the entire surface with a white color, then we're doing all of our drawing, and then we're updating it to host all of the new drawing. So if we didn't update it, we wouldn't see any of the drawing, And if we don't fill it, we don't clear out the old stuff so that we can, draw all the new stuff and not have overlapping. So those are basically the 3 steps. You clear the screen, you draw all the stuff to the screen, and you update the screen. So those are basically the 3 steps for actually making the frames. Now, we could do this with the position X. However, I don't want to do this. I want to use something called classes because they work so much better for when you actually are using non-completely, like if you use an object that isn't static, it's better to make a class out of it just because it lets you do so much more. Even then, it might be better to make a class just to, quickly develop all of your static objects if they're similar to each other. So if you're new to programming, this is the idea of object-oriented programming. Personally, I find it easier to understand than, constantly doing this stuff. So maybe you will, maybe you won't, but I'll try and go into detail about it. So if you want to define an object, you need to call it class. So we're going to call something in Python called class. Now, class, we now have to give this a name. I'm going to call this a player active, which is the name of the class. This is going to be our active player. And we have to give it a couple of parentheses and a colon just to let it know everything down here is the actual player. So whenever you create a class, you have to create its constructor. And how you do that is you say define a function, which is underscore underscore init underscore underscore parentheses self, and PyCharm finishes that for you. And this is the constructor. So when you create something, when you create this class, when you make this, all it does is the first thing is it calls the constructor. That's what it's doing. In the constructor, what do we want? Basically, this happens once per lifetime of whatever this object is. So once per lifetime of a box, what do we do? Well, maybe we say something, like its image is equal to a Pygame surface of what? 100 by 100? That'll work. Because, one time we define its surface. That's the only number of times you really need to define it. But we don't call it image. We're going to call it something else. So when you work with class, you'll notice there's this weird thing called self. What is self? Well, self refers to this object. Not the class of the object, but the specific object. So when we actually create something from a class, like this is just a definition of what we're using. When we actually make something, we would call it, player equals the class, which is player active. This is what we say. So now player is equal to this. Well, what is this? This is currently just an image that is a Pygame surface. But if we use the keyword self.image, then what's happening is self refers to itself. It's self-explanatory. Okay, so I'm explaining this absolutely terrible. So let's go over to this example test and actually work on something that will hopefully help to understand this. So I'm going to create a class and I'm going to call it a person, right? And then I'm going to define its initializer. So define init self. Okay, I'm typing this too fast. I'm just messing up. So define init self. All I'm going to do is I'm going to say self.name equals name. Well, where is name coming from? Well, when I create a person, I'm going to make you name the person. This is all I'm going to do. So now, what we're going to do is we're going to say person1 equals a person, and we're going to give them a name. What is the first person's name? Let's just go with John. Person2 equals a person. So it's the exact same definition, which means we need to give it a name. So I don't know, Amy. There, person2. So we have John and Amy. So person1 is a person, which means the thing we pass in, this string, is the name. And self.name gets assigned name. So what does this mean if we come over here and we say print person1 dot name. So we're saying, person1, which is a person, which is the same thing as basically calling self. Basically, these two are replaceable, except self is used inside of the definition, where person is used outside of it. So we say person dot name, so we're calling this thing. When we print that, we should print out name, which should be John, because we're saying person1. Let's test this. Let's run it. John. Okay. What if we change that to person2? What happens now? Well, now we go to person2. Okay, we're calling its name. So person2 dot name is equal to name. Well, what was name? Well, that was Amy. All right, so we should print out Amy. Okay, so this is the thing about classes. Self.name, we use it once. We only define it once. It's a single variable, but it's referencing self, which means the person1 name is not the same thing as the person2 name. Now, let's do something else. Let's say self.id, and I'm just going to set this equal to, say they're like 10. ID, they're the 10th person in existence, or I don't know. Just some arbitrary number. It doesn't really matter. So now when we say person2, or we're going to go person1 dot ID. So let's print it. So now we print 10. Now if we say person2 dot ID and we print it, we're also getting 10. These are two different values. Just like the name, they are two different numbers. Now, it looks like it's the same number, but person1 has an ID that's equivalent to the value of 10. Person2 has an ID that's equivalent to the value of 10. The same way, person1 has a name that's equal to name, which is passed in as John. And person2 has a name that's equivalent passed in as Amy. Each of these are unique to these variables because these are class objects. These are the actual object. So you can see that if I just change this thing and I say ID, and then instead of it being equal to 10, I say it's equal to ID, and then say I pass in 12 for John, I pass in 13 for Amy, person2.id, that's what we're printing, should print out 13. Now if we print out person1.id, we should print out 12. There, we printed out 12. So these values are unique to these variable names because we're just creating the object. This allows us to define one object and then create a whole bunch of them without having to constantly make them again. So the reason we pretty much use objects and have this is very long explanation is because it allows us, instead of having to say pygame.draw rectangle and then maybe surface is a pygame surface, then maybe draw another rectangle, we can just create this object, and maybe, we wanted another object, player2 equals a player. And then that will take care of the image, that'll take care of the rectangle, that'll take care of how it moves. It'll handle everything for us, and all we have to do is define it again. We don't have to, constantly come down here and fill it and position it and do all of this stuff. It's a shortcut. And you'll see that shortcut more in place. But for now, I'm going to leave that as the explanation of a class. Hopefully it makes some sense. If not, then maybe you'll understand it later. So we have an image right now for our player. Let's get back to the player. So self.image. Well, self.image.fill, we want to fill this with a color. What color might that be? Let's create a blue one. So that's going to be 00255. So now we're filling it with blue. And now we need to get something from this image. So we're going to call another thing self.rect, which is going to be short for rectangle. And we're going to set this equal to the image, self.image.get_rect, which is a pygame function. So now we're going to get the rectangle. What is stored in the rectangle is the start, its x position, its y position, how wide it is, how tall it is. Just basically, it's this. It's the rectangle. That's what's inside of this. So now what we can say is self.rect equals, or self.rect.x equals 100. Self.rect dot y equals 100, and this positions it for us. So now this thing's x position is 100 and its y position is 100, which means x position is 100 and y position is 100. This one's 100, 300, so they won't exactly line up, but those are the positions for it. So here, let's put this back to 200, 500, I believe it was. I don't think it was 500, 200, 400. And I'm just going to put that back so we stop getting errors. We update. Okay. So we have a player active. We've called it player. And it has an image. We fill the image, has a rectangle. We set the rectangle's position. This thing is good to be drawn. So how might we draw this thing? Well, we know player is how we reference into this. So let's do something we know based off our other surface. So I actually want to draw it up here just to show something. So we're going to do this game window dot blit player dot image at player dot rect. So this is going to take the player image, which is the surface, remember, a Pygame surface, and it's going to place it at the rectangle, which is currently set at 100, 100. That's the position where we're going to place it. Let's run this and see that. So now we have this blue rectangle at position 100, 100. All right, that's cool. It's just an object. We've placed it. And we don't have to actually draw it outside of this. Now, I'm not going to do this to save time because we don't really have enough time to show all of the examples of this player. You will see it extensively with the enemy, and why classes are so useful when we actually get to the enemy. Because we're only going to define the enemy once. We're going to create one enemy class, and then we're going to draw hundreds of them, and it's going to be great without having to actually specifically say, self.image or image enemy2 equals a Pygame surface of blah, blah, blah. So basically we're going to define an enemy once, and then we're going to be able to draw hundreds of them without actually having to specifically, individually draw them, basically. And that's when you'll see why classes are so good. If you don't understand them, if you know what classes are, you already know what I'm talking about, in which case, good for you. So we're drawing it. All right. How do we plan on moving it? Well, I want smooth motion. So what we could do is I'll say, if we wanted to, inside of the, for loop of the events, we can say something like if event.type equals pygame.keyDown, and then we can say if event.key equals pygame.k underscore right, then what we could do is we could say player.rect.x plus equals 15. So this might be slightly confusing. What we're saying, if the event is a key down, meaning if a key was pressed, right? If any key on the keyboard is pressed, if that key is the right arrow key, then player, which is this, we take our player object, dot rect, which is this, dot x, which brings us here, plus equals, which is the same thing as saying equals player.rect.x plus 15. It basically adds 15 to that value. So we're adding 15, meaning this would become 115 if we push the right arrow key. So let's see. All right, here's the problem with this method. If you hear me mashing the key in the background, I have to push it every time I want it to move. Now, if you want to break your keyboard trying to move across the map, be my guest. I don't really want to. I want this thing to move when I hold the key down. And the way I'm going to do that is a bit different. And it actually doesn't use the event system. Now, of course, to get full movement, you would just say if event.key equals pygame.keyLeft, .key up, .key down, and of course change the x to minus equals 15 to move left, or the y to move up and down. That's how you would do this. If you want to do it this way, it's your choice. Maybe you want to have to push the arrow keys every time you move. However, for this game, I don't want to do that. So what I'm going to do is inside of the game loop, I'm going to create something, a variable name, called active key, meaning this is the key that's currently active that's being pressed. And this thing is going to be equal to pygame.key.get_pressed. And this is going to get what active key is going to be set to whatever key is being pushed down. And now we can create an if. So we can ask it if this key is the one we're looking for, do what we want to do. So if active key, and this is where it gets weird because we have to give it square brackets because this is a dictionary, I believe, which means we need to get the key's name. Well, we know that key's name is going to be pygame.k_write. So if the active key is this key, pygame.key_write, what do we want to do? Player.rect.x plus equals, we're going to go with 1. And let's see what this looks like. Okay, I just held down the key. I can't really reset it without running it again. But I'm only going to push the key once. Let's see if you can still hear that. And it zooms away. Alright, that's cool. So now we can do this. Whereas we could do this with all keys, right? We can say, now we can go if active key, pygame.key_left. So if the key is the left arrow key, player.rect.x minus equals 1, which now when we run it, you'll notice we have left and right control. So now we can zip back and forth really fast. So this works, and of course we just have to add up and down, which isn't too hard to do. So, if the active key, pygame.key_up, then player.rect.y. If it's up, we minus equal 1. And the reason we minus 1 is because the top left corner is 0, 0, and the bottom right corner is max, max. So when you move up on the screen, your y value is decreasing. That's something that usually takes a little bit to get used to. So active key, pygame.key_down, which is the last one, and I'm just doing this in full so you can see all of the key names that they're what you might expect them to be. And then player.rect.y plus equals 1. So now let's run this, and we should have full control over this box. Alright, that is pretty sweet. Now we can move our box around. However, it's moving ridiculously fast, and in a game you probably don't want it moving this fast, just because it's almost sporadic how quickly it's moving. And of course, if we want to, we can change these to WASD keys. I'm going to leave them to the arrow keys for now. I might change it later when we actually get into using the mouse for, a shooting mechanic. But you can see that this box moves around. And you can also see we're drawing this red one last. And you'll notice, like I said, the inside's still hollow. So we can just move under it with ease. So this is how you would do smooth movement. Of course, we need to limit the frame rate. But I don't really want to do it this way. So, like I said, we're going to focus on movement. And I'm just kind of showing you all of the possible steps to get movement. So I don't want to specifically here tell the player X to move. What I want to do instead is say player.move, and when we're hitting the right key, we're moving positive in the X direction, and we're not moving in the Y direction. So again, player.move. For the left, we're moving negative in the left direction, and we're not moving in the Y direction. And then we're going to call player.move again. And now when we move up, we're moving nothing in the X direction, and we're moving -1 in the Y. And of course, the last one is going to be the opposite of that. We're going to be 0 in the X and 1 in the Y. So player.move. Well, what is move exactly? Because move isn't defined. We don't have a variable name for it. So What are we trying to do with it? Well, I'm going to create a function inside of the player class. Now, I know I'm doing a lot with classes, which means you're probably completely lost, but we're going to create a class called move. So what we're saying is when we call player.move, we're calling this. And we're giving it two arguments. So we're giving it an x direction and a y direction. Those are the two arguments we're feeding it. So what do we want to do when we call move? Well, self.rect.x plus equals x direction times self.speed self.rect.y plus equals y direction times self.speed. And let's define the speed up here. Self.speed equals how fast do we want this to go? We'll leave it at 1 because, like I said, our frame rate is as fast as it can go. So we're moving 1 pixel every frame, but we're getting like 500 frames a second, so it can be problematic. So now what we're saying is we're saying when the key is the right key, do player.move 1, 0. And what this is doing is it's passing 1 and 0. So it's saying self.rect.x, the x position of this, plus 1 times the speed. So we could turn the speed to 5, and it will move it 5 pixels over every time this happens. We can set speed to 10 and move it 10 pixels over every time without having to change 4 values down here. And we can also add more stuff into the move function. Maybe every time it moves, we want to print something. Who knows? Maybe we want to play an animation where, say, our character, every couple seconds he, changes his foot on his image that he's walking. So it actually looks like he's walking, kind of animate it. We can do that all in the move. And you'll notice when I run this, it works exactly the same. We still move, exactly like we did before, except now it's a nice little function inside of the player object. Which means, 1, it's easier to edit, so if we want to, we can change the speed to 2, which will be ridiculously fast. Or we can add more stuff into the movement. Yeah, it's much faster now. Or we can add more stuff into the movement to change how things happen. So actually, how about we do that? So when we call this move function, let's do something like self.image.fill, and I'm probably going way over the amount of time I want to use. Let's fill this thing with red, 255, 0, 0. And then I want to do one more thing, maybe. The only issue with this is when we're not moving, we're not going to change back, basically. Alright, for the sake of time, I'm just going to do this one quick thing. We're going to go with else. So, if else statement, we're going to say else, so if we don't move when we go right, what's going to happen is we're just going to say player.image.fill, and then our natural color was blue, so 0, 0, 255. And all this is going to do is if we move right, or if we don't move right, set our image to blue, otherwise set it to red. Now this is going to look a little weird, but it should work the way I want it to. So let's see. There you go. Now, when we move anything, you'll notice whenever we're moving, we're red. Which means I think I just lost it. Yeah, I went too far one way. So let's run this again, because we have no boundaries, so we can't get the box back. I'm actually holding the left and right arrow keys right now, so it's moving left and then it's moving right, the exact same amount, so it's not moving. And you'll notice we keep it red. But I let go of both of them, and it turns back to blue. So you can see inside of the movement, we can give it this, epileptic effect of constantly switching colors. So that's what you can do with having the move function, and it's a lot easier, because if we didn't have the move function, remember, we would have to tell it to switch colors every time it's moving and then have an else statement every time it's not moving to switch back. So that's one thing we can do. I'm going to just clean this up right now because I don't want this to keep being there. We can do this a different way, a little bit better. There's a way to actually check if any of these are true in one line, and then basically for each one that's true, do it instead of having 4 if statements. But we may or may not clean that up. I don't know. It depends if I actually need some kind of movement animation. Anyway, this one's gone on way too long. So, thank you for watching. Hope to see you next time.